In this video, we are going to look at ionic bonding. When you look at some of the noble gases like helium, neon, and argon, one thing in common among all of them is that they are stable. That's why sometimes they are called inert gases, noble or inert gases. So this stability in these noble gases is what most other elements tend to try and attain. They want to attain stability. So when we are looking at bonding, we tend to obtain stability. So atoms like maybe sodium, chlorine, oxygen, in whatever they do, whenever they want to undergo a certain kind of reaction that involves bonding, they will have to do so in the process they want to attain stability. So when you look at helium, its electronic configuration is 2, neon 2,8, and then argon 2,8,8. So what is common in all these three is that they are stable, like I have said. However, when you look at helium, it obeys the duplet rule of having 2 electrons in the outermost energy level, while these other two obey the octet rule of having 8 electrons in the outermost energy level. So in our ionic bonding, we are going to see metals and nonmetals working towards the ability of having either 8 or 2 electrons in their outermost energy level. In the due process, they will be becoming stable, just like man might also want to become stable, probably by getting more money, or by marrying, or by changing location, or by his team winning, and so on. So stability is what all these atoms want to achieve. So they do so by having either 8 electrons or 2 electrons if at all it's the first energy level. So in our next slide, we are going to see how sodium and chlorine can actually bond to form what we call ionic bonding. So a bond is basically a force of attraction between atoms or ions, a force that keeps atoms or ions together. So it's basically a force of attraction between atoms, or between force of attraction between atoms and ions. So we are going to look at ionic bonding, and we shall discover that in ionic bonding we shall form what we call ions. So let's dig deep and start looking at the reaction between sodium and chlorine. So just like the name suggests, ionic bonding, it comes from the word ion, and an ion is basically a charged particle. So we all know that atoms are electrically neutral. However, when atoms lose or gain electrons, they tend to become charged because they will have an imbalance between the positively charged protons and the negatively charged neutrons. Let's have a look at sodium chloride, the bond between sodium and chloride. So you know that sodium chloride is our table salt known as NaCl, or common salt. So we are going to see how sodium chloride is formed, and then we shall try to understand what ionic bonding is. So when you look at sodium, Na, sodium has atomic number 11, while our chlorine has atomic number 17. So this means that the electronic configuration of sodium will be 2, 8, 1, while that of chlorine will be 2, 8, 7. So we have 2 electrons in both cases for the first energy levels, because the first energy level can only take a maximum of 2. So what happens is that when you look at our sodium, we said that these atoms also want to gain stability by having 8 electrons and not 1, while our chlorine will also want to have 8 electrons and not 7, so as to follow the octet rule. That tells us that you should have 8 electrons in the outermost energy level to be stable. Yes, so all these two atoms, the sodium atom and the chlorine atom, want to have 8 electrons in the outermost energy level. So let us see what exactly happens. So when you look at sodium, if I sketch the outermost energy level, okay, let me sketch all energy levels. So if this is my sodium atom, Na, so the first energy level, we have our second energy level, and then the third energy level. So we have 2 electrons in the first, so I can write here 1, 2. Then we have 8 in the second energy level, 1, 2, 3, 4, 5, 6, 7, 8. And then lastly we have our 1 electron in the last energy level. So the one for chlorine will be slightly different because it has 7 electrons in the last energy level. So sketching it very fast, have our chlorine, 2 electrons. We have the 8, 1, 2, 3, 4, 5, 6, 7, 8, and then the third energy level for chlorine will have 7, 1, 2, 3, 4, 5, 6, 7. So we are going to see what exactly happens by drawing the last energy levels for sodium and chlorine, so that we can try to comprehend the transfer of electrons. In ionic bonding, we have the transfer of electrons from the metal to the non-metal. So electrons are transferred. Electrons are transferred. So what happens is that we are going to see the following taking place. We shall have our sodium atom, and then we shall have our chlorine atom. And when this happens, our sodium atom has 2,8,1, 2,8,1, while our chlorine atom has 2,8,7. So when the transfer takes place, we shall then form a sodium ion. So this is sodium ion plus our chloride ion, and we shall have a change in the number of electrons for sodium. So we shall have 2,8, and then chlorine 2,8,8. So as you can see, in both scenarios, the ions formed will both be having 8 electrons in the outermost energy level. So in the due process, they will be stable. When this 1 electron for sodium joins the 7 of chlorine, we shall then form these corresponding ions. And we all know that different charges will always attract. So we shall have a compound of sodium and chloride ion being attracted because opposite charges always attract. So the attraction between these two ions is what we shall call the ionic bond. So let us try to draw some diagrams so that we can try and comprehend it better, starting with our sodium atom. So we have our sodium atom, however we shall draw the last energy level or outermost energy level in this case. So we have our sodium with 1 electron. Then we have our chlorine with 7 electrons. So we shall have to sketch all the 7 electrons, 1, 2, 3, 4, 5, 6, 7. So what happens is that we shall have a transfer of this 1 electron of sodium from sodium to chlorine, and then in the due process we shall form our products in this format. So the last outermost energy level for sodium will be lost. So we shall end up forming our sodium ion, and then we shall also form our chloride ion. Okay. So this is our sodium ion with the 8 electrons from the second energy level, not the third. The third will be lost. So we shall have our sodium ion and our chloride ion. So chloride ion, I'll still draw only the outermost energy level. So this one electron is the one from sodium, the one in white. However, the other blue electrons of the chlorine ion will stay behind. So what happens is that the force of attraction between this positively charged sodium ion and this negatively charged chloride ion will bring these two ions together so that they form one thing. So we shall have sodium, shall have something like this. We'll have our sodium ion and then our chloride ion being brought together to form the ionic bond of sodium chloride. As such, we shall say we have formed sodium chloride by the transfer of electrons from the metal to the non-metal. And ionic bond basically involves the formation of ions, because we are seeing the positively charged sodium ion, which is a cation, and the negatively charged anion. So that's why we call it ionic bond, because it involves the formation of ions. Yes, if you have a question concerning this video, please leave it in the comment section, or any idea on which other concept we can look at. I'll be glad to hear from you. Thank you for watching. See you next time.